Okay, the first problem on the study guide for test 3, 28 is 20% of what number? The second problem is also this type of problem. It's a percent sentence problem, so you have 28 is 20% of what number? So you have that is and of in there, and as soon as you start seeing that type of structure, you want to set up a percent proportion. You immediately put a 100 on the bottom of one of the fractions. Always start with the percent. So it says 20%, that's the first place I go. Whatever that is, I'm going to put that over the 100. Now, you always want to deal with the percent first, so that when you look at is, there were two things next to is. We've already used 20, so we don't use that one, so we're going to use 28 on top. Is goes on top. And the word of is next to two things also, but again, we've already used 20%, so we don't use that one. What number means unknown, and of always goes in the bottom. So is over of equals the percent over 100. Once you get the proportion set up, you cross multiply. That product of 20x is equal to that product of 2,800. We divide both sides by 20. Number in front of x, we end up with x is equal to 140. Problem 2, again, same exact structure. What number is 140% of 60? So I see a percent proportion going on here, so I set it up. Always put the percent first, so 140% goes over 100. It doesn't matter if it's above 100%, below 100%. If it says something percent of, percent goes over 100. And then it says what number is. Again, is also next to 140, which we already used. Unknown goes on top for is. Of 60, so 60 goes on the bottom. And just like that, we've got another proportion we can solve by cross multiplying. This product, 100x, is equal to this product, 8,400. To solve, we simply have to divide both sides by 100. 8,400 divided by 100 is 84. So first two problems, both use percent proportion. Again, there's three pieces, piece 1, piece 2, piece 3. You're always given 2 and looking for the third. This is always 100, so make sure that you set that up properly. Problem 3 asks us to graph an equation. This is a linear equation, 2x plus 3y equals 6. Anytime I want to graph a line, first step is to get y equals. First step of getting y equals is getting anything that's not y to the other side. So 3y stays right where it's at. I'm moving 2x to the left, or sorry, from the left to the right, so it changes to a negative. 6 is staying right where it's at, so it stays positive. That's the structure I want in my equation every time. The y term equals the x term plus the constant. Then we divide by 3 because we don't want anything but just y equals. Divide each term individually by 3. Those 3's cancel, leaving y. Negative 2/3 doesn't reduce, so leave it as negative 2/3. 6 over 3 reduces to 2. This is slope-intercept form of the equation. The number that is the constant is the y-intercept. And that's where on the y-axis the line crosses. So at positive 2 on the y-axis, so 0 is the origin, positive 1, positive 2, that dot belongs on the line we're trying to graph. Next thing we do is we look at the slope. The slope is the number in front of x. Slope is a negative fraction this time, so I can either have a negative number on top over a positive, or positive on top over negative. Both of those are a negative 2/3. Using this one, negative 2 on top is down 2. Positive 3 on the bottom is right 3. On this one, positive 2 on top is up 2. Negative 3 on the bottom is left 3. Either one of these directions, this set of directions or this set of directions, will give me an extra point on the line. So, these in different colors here. Let's do this one here in blue. Right. So, if I'm at this point right here, and I apply the green directions, I go down 2 and then right 3, I end up at this point. If I start at this point right here and apply the blue directions, go up 2 and left 3, I get that point. All 3 points line up on the same line, so it doesn't matter. I can use this or this. I don't have to use both. Just know that either direction is possible. Once I've made my points, then I just connect the dots with a nice straight line, putting arrows on the ends, like so, and that's the answer. So graphing the line, that'd be the technique I use for the test. Get y equals, identify the y-intercept as a starting point, use the slope to get a second or third point, connect the dots, move on to the next problem. Number 4 is based on a property. There's 180 degrees in a triangle. There's our property. The angles in this triangle are x minus 5, 2x minus 10, and 2x minus 5. The rule says those three angles have to add up to 180, so that's how I'm going to create an equation. So x minus 5 plus 2x minus 10 plus 2x minus 5 equals 180. All three angles add up to 180. Said all three angles equal to 180. Add it up. Adding like terms, x plus 2x makes a total of 5x. Minus 5 minus 10 minus 5 is minus 20. So you get the equation as simple as possible. Then simply solve the equation. 20 moves over here, becomes positive. Anytime you move across the equal sign, you change the sign. 180 plus 20 is 200. Divide both sides by 5 to get rid of the coefficient. End up with the next value of 40. Test is going to ask for x, so that's it. The other thing they might have asked for is how big is each angle. In which case, come back here, 40 minus 5 is 35. 80 minus 10 is 70. 80 minus 5 is 75. So we could have found exactly how big each angle is, but again, the test is only asking us for what x equals, so finally get that. Number 5, find x. We have two angles in this problem. The lines are marked parallel, so we have parallel lines cut by transversal. The properties involving parallel lines cut by transversal say that acute equals acute, obtuse equals obtuse, and acute plus obtuse equals 180. Those are it. So there's specific names for these things: alternate interior angles, consecutive interior angles, corresponding angles, that kind of stuff. These actually are called consecutive exterior angles, if you care to know that. But I can see this angle here is less than a 90-degree angle. 90-degree angle's an L, that's less than an L, so it's less than 90. That makes it acute. This angle, on the other hand, is right here. It opens up much wider than 90 degrees. 90 degrees opens up wider. That makes it obtuse. And the rule that I'm going to apply here says an acute plus an obtuse equals 180. So I'm just going to take these measures, add them up to 180. So acute, 3x minus 19 plus obtuse, 4x plus 10 equals 180. Combine like terms, 3x and 4x is 7x. Negative 19 plus 10 is negative 9. And if 7x minus 9 equals 180, we move the 9 to the other side, therefore 7x must be 189. We divide both sides by 7, ends up with 27 for x. So if this were an acute angle, so suppose this had been here instead, then I would have used this back, this equals this out of my equation. So again, depending on what you're looking at, you make the equation based on what you're looking at. In this case we had an acute and obtuse, so we used the acute and obtuse out of 180. But again, if they're both the same, set them equal to each other to make the equation. Number 6, find x and y. X is in this expression, y is in that. So we've got 180 degrees in a triangle, but I got too many letters in the triangle to be able to use that right away. What I can use right away, though, is the fact that this is a straight line right here, and this angle, this segment here cuts this into two separate angles. So right there at that corner of the triangle, this angle and this angle have to make 180. So I know that 130 plus 2x minus 30 has to equal 180. Because again, they make a straight line, again using a property of math to do this. Simplifying gets me 2x plus 100 equals 180. 130 minus 30 is 100. When we move 100 to the other side and subtract, we divide divide by 2 to get x equals 40. That's how we find x. Once I know what x equals, I can very easily find the measure of that angle. That's 2 times 40 is 80 minus 30 is 50. So at this point, looking at the three angles of the triangle, I got 50 and 30 and 5y plus 10. Those three angles add up to 180. So therefore, I know that 50 plus 30 plus 5y plus 10 has to equal 180. And then it's just a matter of solving that equation. 50 and 30 and 10 make plus 90. 5y doesn't have any like terms, nothing happens to it. We move the 90 to the other side, we change its sign to allow for that. 5y equals 90 divided by 5 gives me y equals 18. So 180 degrees in a straight line, 180 degrees in a triangle. After you find x, use x to find the measure of that angle to be able to find the answer to that equation. Number 7. Got a decimal equation. Main idea for decimal equations is to find out how many decimal places is the most in any term. So I've got 3, 2, 2, and 3. 3 is the most, so I want everything to have 3 decimal places. So first step on my paper would be to rewrite this problem, everything containing 3 decimal places. So 0.001x, 3 decimal places in the number, plus 0.04, I'm going to add a 0 at the end to make a third decimal place, stick an x on it. Minus 0.09, had to add a 0 to get a third decimal place on that. And 0.238 already has 3 decimal places, so it's fine the way it is. Once everything has 3 decimal places, drop all the decimals off, and you're left with a equivalent equation that has no decimals in it. So this becomes 1x, this becomes 40x, this becomes minus 90, that becomes 238. And just like that, I've made a much easier looking problem that has the same answer. It's easy enough to do. I do recommend, if you have this thing going on here, to actually put the 1 there so that there's no mistakes and simplify. 1 plus 40x, 1x and 40x makes 41x. And if I move the 90 to the other side, it becomes plus 90. And it gives me 41x is equal to 328. Dividing both sides by 41 gives me x equal to 8. Number 8, another solving equation problem. This time the key to this problem is simplification, doing it correctly, so be careful in the process here. The first thing I want to do here, 2 to the 0 power is equal to 1. The minus sign is not being raised to the power, so it stays negative. 3 to the second power equals 9. The minus sign is not being raised to that power, so it's minus 9. This is a subtraction sign here, so it should either be subtraction or addition, but again, its subtraction stays that way because this is being squared, the minus sign isn't being squared. Here, negative 2 cubed, so negative and 2 are both being cubed. This minus sign isn't, so that minus sign I'm going to just bring down. Negative 2 cubed is going to be negative 2 times negative 2 is positive 4 times a third negative 2 makes negative 8. Then I have a distributive property situation. There's only a 1 in front of this, so I'm not multiplying anything but 1, but it is a minus sign, so minus is going to distribute through the parentheses. Minus 3, minus 3x is going to be plus 3x. Once again, it's this number minus, so it's this number minus and subtraction. This is not multiplication occurring here. This is subtraction, so minus 3 and plus 3x is what we get out of that. Equal sign happens, and then finally we have this one here, another distributive property, negative 2 being multiplied through this parentheses. Negative 2 times negative x makes positive 2x. Negative 2 times positive 8 makes negative 16. Okay, so that's step 1, fixing the powers, getting the distributive property, having to get rid of the parentheses, making the problem simpler than it was. The next thing I would do personally, I see minus 8, I prefer to make plus 8. At this point, these are all like terms, so I can add and subtract those. 3x isn't, 2x and minus 16 aren't, they're on the other side. So, negative 1 minus 9 is negative 10, minus 3 is negative 13, plus 8 is negative 5. And just like that, we get ourselves down to a reasonable level equation, pretty easy to do. We move the 2x to the left, move moves across the equal sign, so it changes sign. Moving the 5 to the right. It also moves across the equal sign, so it changes sign. These are opposite signs, so I subtract. 3 is bigger, so it's positive. These are opposite signs, so I subtract. 16 is bigger, so it's negative. So x equals negative 11 is the answer to that. The challenge of the problem does not lie here, it lies up here in the simplifying. So be careful in that step, going from here to here, and then from here to here, completely simplifying it. The leftover equation should be pretty basic for anybody in this class. Number 9, another equation. This one has fractions and mixed numbers. First thing I would do is I make everything into an improper fraction or a proper fraction if it already is. So negative 1/3, I'm going to leave as is. I've got plus 2 1/4. That's going to become plus 9/4. 2 times 4, 8, plus 1 is 9. Put that over the denominator. Next term is minus 3 1/3. I'm going to make that minus 10/3. 3 times 3 is 9, plus 1 is 10, goes over 3. Next one is 2.5x. I'm going to get plus 5/2 x. I personally like to put my x's on top. That's where they actually are, so just to make sure that I don't think that it belongs on the bottom. So 2 times 2 is 4, plus 1 is 5 over 2, and again the x I just slide up on top. I got equal sign, and my last term here, 4 1/6. 4 times 6 is 24, plus 1 is 25, that goes over 6. So that's priority 1, make every single mixed number into an improper fraction. Keep the proper fraction as is. Next step I do is I'm going to get rid of the fractions, because it's much easier to solve an equation with no fractions in it. Common denominator of 3, 4, 3, 2, and 6 is 12. That's the least common denominator. 24, 36, 48, 60, 72, 84. Any one of those would have worked also, any multiple of 12. But the least common denominator, the smallest number divides evenly by all those numbers, is 12. A fraction is a divider first, multiplier second. So 12 divided by 3 is 4, multiplied by negative 1 makes negative 4. 12 divided by 4 is 3, times positive 9 is positive 27. 12 divided by 3 is 4, times negative 10 is negative 40. 12 divided by 2 is 6, times positive 5x is positive 30x. And 12 divided by 6 is 2, times 25 is 50. Just like that, the equation is now just nice and friendly, no fractions left. I do have some like terms over here on the left-hand side, so maybe I'll add those together. Negative 4 plus negative 40 is negative 44, plus 27 is negative 17. So negative 17 plus 30x equals 50. Move 17 over here, that gives me 30x equals 67. 67/30 is the final answer. And improper fractions is a fine way to leave a final answer. I wouldn't go any further than that. You want to make it a mixed number, it's 2 7/30, but I leave it right there. Number 10, expand using the distributive property. What you'll notice is we have this object here, which is being multiplied by this object and this object. I want to rewrite the problem in simplest form. So I want all the things circled in blue, red, and purple there to be simplified so all the powers are positive. I don't want to have any multiple letters happening in those objects. So 2 to the 0 power equals 1. The minus sign is not being raised to the power. X to the first power and p to the second power right where they belong, so they stay right where they're at. For the red term, nothing at all is wrong with it. Some people see the minus 2, they think it has to move to the bottom because you see a negative. It's negative 2 to the first power. The power is positive. It's right where it belongs. So minus 2 is fine. P squared is fine. X to the first is fine. The plus sign occurs. The purple term. 5x and y are all on top behaving themselves. P squared is on the bottom to a negative second power. That belongs on the top. Everything came off the bottom. I would put a 1 down there. The next step I'm going to show you is the step that most of you are getting them wrong right now or leaving out. You just don't want to do this step. I don't know if it's stubbornness, laziness, you think you can handle it, but a lot of times I see wrong answers, people are skipping this step. So if you want to get the right answer more often than not, don't skip this step. Multiply this fraction times this fraction. Multiplication of fractions is top times top, bottom times bottom. Don't try and reduce while you're multiplying. Just multiply it out and get what you get. So 2 negatives make a positive. 2 times x times p squared makes 2x p squared. On the bottom, p squared times x makes p squared x. Second term. Negative times positive makes a negative. 5 is the only number on top, nothing happens to it. X times x makes x squared. Y and p squared times no other y's or p's stays y and p squared. On the bottom, p squared times 1 is just p squared. Okay. I can see that p squareds and x's are the same and the p squareds are the same. I can see all that stuff. Save that for the next step. Just get your answer, get it in unsimplified form, and then go ahead and simplify to the next step. So this is the step people are leaving out that are getting wrong answers more often than not. So if you put that step in, you're more likely to get it right. This term here, this first term, x is the same as x, they cancel. P squared is the same as p squared, they cancel. If they're exactly the same, they just cancel. So they're just gone. 2 is left over. If everything happened to cancel here, there'd still be a 1 left over that has to be written. On the second one, p squared is the same as p squared, they cancel. Everything else has no like pieces, so nothing happens to it. So 5 x squared y. That is the simplest version of the answer possible. Number 11, this is all about your simplification of rules based on laws of exponents. These are also problems that are missed quite a bit, mainly because I think some of you guys are trying to skip steps. It's a 4-step process. Each step involves simple multiplication, moving some negatives around, simple addition, simple subtraction. So there's nothing difficult in arithmetic in these problems. The challenge is doing things in the right order and not trying to do 2 things at once. So first thing I focus on in these problems is this structure here. If I see a parentheses to a power, this officially is a parentheses to a power, even though there's no power outside. It's officially the first power outside, so that counts. So what I'm going to do in the first step is anything that doesn't have that look, I'm just going to bring it down. So 5 and x to the 4th stay right where they're at. 4 to the negative second stays where it's at. X squared, y cubed, x to the first. I put a first power on the x, so everything has a power. And then I'm going to tackle the parentheses to a power issue by multiplying powers. So the bases stay y and x. Power times power gets me the new power. Negative 3 times negative 2 makes positive 6. 2 times negative 2 makes negative 4. On the bottom, the bases are x and y. They stay x and y. Negative 3 times 1 is negative 3. 2 times 1 is 2. So that's how you deal with the parentheses situation. Multiply outside times inside power. 2 negatives make a positive. Opposite signs make a negative. We don't want to deal with negative powers in this step because notice this negative power changed to a positive. That positive changed to a negative. You start getting wrong answers if you start, or not necessarily wrong answers. You just got extra steps if you try and deal with the negative powers too early. Next. I've got a negative 4th power, I've got a negative 3rd power, I've got a negative 2nd power. Those 3 things circled in green have to move. Everything else is exactly where it belongs. So, everything where it belongs, I'm just going to leave it where it is. I'm going to write it in black. So, a 5 on top, an x to the 4th on top, y to the 6th on top. I've got an x squared on the bottom, a y cubed on the bottom, an x to the 1st on the bottom, and a y squared. This little y squared over here is kind of hiding between these. Sometimes people leave those terms off, so be cautious that as you bring stuff over that you're copying everything back down. The 3 things circled in green need to move. 4 to the negative 2nd power belongs on top. I like all my numbers in front, so I would probably put 4 squared right there. When you move a negative power where it belongs, the power changes to a positive. This x to the negative 3rd power belongs on top. Again, negative 3rd power on the bottom, positive 3rd power on top. This x to the negative 4th belongs on the bottom. Negative power on top, positive power on the bottom. So the 3 green objects there moved, the powers changed to positives. So that's all step 2 is, move the negatives where they belong. In step 3, I'm going to deal with multiplication on top. So the top is a problem and the bottom is a problem separately. So numbers need to be evaluated in this part. So if you have a number to a power, if you have multiplication or division happening, you need to reduce fractions, that kind of stuff, that's going to happen here. Letters of the same type on the same side, so x's both on top, those have to be dealt with. I got these x's on the bottom, they need to be dealt with. I've got these y's on the bottom, they need to be dealt with. Make those orange. Okay. So, if I'm dealing with each of these things as I see them, I've got my fraction bar. In the purple, 4 squared equals 16, which is being multiplied by 5, which equals 80. So what I have circled there, 16 times 5 is 80. That's the numerical value. Again, evaluate to the extent you can. Looking at the x's, I got x and x. The rule says to add powers when I multiply x's. 4 plus 3 is 7. I've got a y to the 6th that's not doing anything right now, so I'm just bringing it along to the right. On the bottom, I've got too many x's. X. 2 plus 1 plus 4 is 7. Again, multiplying x's, I'm adding powers. Looking at the y's, I've got y. 3 plus 2 is 5. Final step, division. This is the point where I reduce the fractions. If I have a number on top and bottom, I reduce the fraction. Obviously 80 doesn't reduce, so it stays 80 on top. X to the 7th and x to the 7th are exactly the same, so they actually cancel out. Y to the 6th and y to the 5th are not exactly the same. Y is bigger on top, so it belongs on top with 80. 6 minus 5 is 1. 80y is the best answer to that problem. Multiplication of single-digit numbers, move some negatives around. Addition of single-digit numbers plus a pretty decent size multiplication, but it's not difficult. And then subtraction of single-digit numbers. So the math involved in this problem is not difficult. Do it in the right order. Don't try and get from this step to this step, or from this step to this step, or from this step to this step all in one fell swoop. Just try and do it a piece at a time. Do what you're supposed to do. Pay attention to detail through the process. Don't forget about this lonely little y squared hanging out over here off to the side. Sometimes that gets left off, that kind of thing. So those types of mistakes are the ones that are happening. Be careful. Number 12. We're adding like terms. In order to add like terms, we first have to know if they are like terms. When they look like this, I can't tell. So my first priority on this problem is to make each term as simple as possible, one of each letter, all powers positive. And this one's pretty complicated, so I might take it in a couple steps. So maybe first off, I would go 3, that's x squared. And then I got a y on top, right? And then the y to the negative first belongs on top. And the y to the negative second belongs on bottom. Maybe I do that first. And I might notice that y times y is y squared. Y squared over y squared cancels. So I end up with 3x squared off the first term. Second term, the 6 is fine. Y to the 0 is 1. It doesn't matter. X squared moves up, so it's going to be 6x squared. Y to 0 doesn't matter there because it's times 6, so 1 times 6 is still 6. It can be thrown out. If it says plus y to the 0, that does have a meaning. Plus 1 does change values. But in this problem, it won't. 3x squared plus 6x squared makes 9x squared. So once you get like terms, they both have x squared on them. X squared goes in the answer. You simply have to add the numbers in front to get the new number in front to get the right answer. Number 13, these evaluation problems. My recommendation up to this point for these evaluation problems, especially when you're substituting fractions in, is begin by doing a distributive property or a simplifying process in order to get this thing as simple as possible. So ab squared times a is a squared b squared. ab squared times ab is a squared b cubed. And by doing that, we've broken this problem into a squared times b squared minus a squared times b cubed. If I can figure out what a squared equals, that can go right there. B squared can go right here. And b cubed can go right there. And those two products are being subtracted. So, if I come back over here to a, this is a is 1/3. A squared is going to be 1 squared over 3 squared. Looking at b, this says b squared, so I want b squared. Square letter, you square sign and number. So looking at b squared, square a minus, I get 2 negatives makes a positive. 1 times 1 is 1, 4 times 4 is 16. Looking at b cubed, again, I'm cubing the sign and the number. Negative, negative, negative makes a negative. On top, 1 times 1 times 1 is 1. On the bottom, 4 times 4 times 4 is 64. So just like that, I've evaluated a squared, b squared, and b cubed. So now over here, I can simply substitute those expressions, those answers in. So a squared is 1/9. It's being multiplied by b squared, which is 1/16. It's being subtracted by a squared, which is 1/9, which is being multiplied by b cubed, which is negative 1/64. So instead of having to evaluate powers with the fractions there, I've already got them evaluated, so it's just a matter of substituting them in. Now I've simply got a multiplication and a subtraction or addition. This product, 1 times 1 is 1, 9 times 16 is 144. Minus minus becomes plus. 1 times 1 on top is 1. 9 times 64 on the bottom is 576. Now, this is not as friendly as some of the other fraction problems, but notice 16 is just times 4 is 64. That's 9. That's 16 times 4. This is just missing a 4 over here. So times 4 on top and bottom, we get our common denominator. 4 over 576 plus 1 over 576 equals 5 over 576. So that's the most efficient way to do that. 14, basically the same idea. This time, I got minus a parentheses, so I'm going to distribute there. So mx just stays mx. And I've got minus m squared, and then minus minus becomes plus x. mx are what I know, m squared I don't know. So if I establish what m squared is, 2 negatives make a positive. 1 times 1 is 1. 4 times 4 is 16. So m is negative 1/4. So negative 1/4 times x 1/3 minus m squared minus 1/16 plus x plus 1/3. That's negative 1/12 minus 1/16 plus 1/3. Common denominator of 12, 16, and 3 is 48. 12 times 4, negative 1 times 4. 16 times 3, negative 1 times 3. 3 times 16, 1 times 16. Just like that, we get common denominators. Negative 4 minus 3 plus 16 is 9 over 48. And that's the answer to that problem.
May I have your attention, please? Seniors, please report to Mr. Wickeiser's room briefly for a meeting before you go to your AC period. Once again, seniors, please report briefly to Mr. Wickeiser's room before going to your AC period.
Okay, this one you just have to pay close attention to detail as far as the structure is concerned. Negative 2 is being multiplied by this entire bracket. That's being subtracted then by that entire bracket. So I evaluate this down to a number, multiply those together, subtract that. If I will worry about this blue bracket first, negative 2 outside the bracket. 3 to the 0 is equal to 1. The minus sign is not being raised to the 0 power. So that's actually negative 1 for that piece. Negative 1 minus 1 is negative 2. 6 times 1 is 6. 3 minuses makes minus 6. Inside the red, 3 to the 0 is 1. It's actually negative 1 because the minus sign is not being raised to the 0 power, just the 3 is. Minus 1 minus 4 is minus 5. And then 3 squared is 9, being multiplied by negative 2. Continuing on. Inside this bracket, minus 2 minus 6 is minus 8. Addition because the signs are the same. Negative because 6 is bigger. In this bracket, 9 times 2 is 18. It'll be positive 18 because of opposite signs. And then finally, up with the blue stuff, negative 2 and negative 8 make positive 16. Negative 5 plus 18 makes positive 13, but that's being subtracted. 16 minus 13 equals 3.